are you guys doing?
Good. Can you hear me?
Yes, sir.
Yeah.
Peter, do you know Chris?
Sorry.
I think Chris and I have met. I like his formula. I wish we could spend an hour talking about the formula on his T-shirt.
Mm-hmm.
You have 10 seconds to figure out what it says.
I can read what it says. I just have not a clue what it's referring to.
E greater than average.
Mike is coming, so he can decode it for us. Peter, Phil McCausland is our new vice president.
Excellent. Is he living in St. John's again?
No.
No.
But since we're virtual, it's all the same, right?
Exactly.
Yep.
I haven't seen Phil in quite a while. I hope he's doing well.
Yep.
People coming on will be starting shortly. We're just waiting to make sure people figure out how to get on. Sometimes they have a hard time figuring out how to get on Zoom, so we'll just wait a second. And while I'm at it, I've got to add Nikolai. Welcome to the St. John Center, Royal Astronomical Society. Thanks, Nikolai, for attending. Okay. Do we have our quota, Randy?
Yeah, I think so.
We don't have to name it.
It's getting up there. It's not 500 yet, but I guess we can go.
I'll introduce myself. My name is Gary Diamond, and I'm the president of the Royal Astronomical Society St. John Center.
I want to thank, congratulations, send out to John for his getting his certificate for finding all the moon objects.
That's the RASC certificate,
Good
observer
job.
certificate. Yeah.
And I'm supposed to introduce our speaker right now. While I introduce my speaker, I'll see if I can fix my side of the thing here. Now, our speaker is the past president of the London Center.
I was president back in the 1970s.
I've known Peter since the early 80s. Most people probably know Peter from reading their page 310 of the Observer's Handbook. He is co-author of Globular Clusters. He, I don't know, Peter, I'm not going to talk about anything. Peter was a part of an exchange. I'll tell you one story. Peter was part of an exchange. He was a mainlander coming down to give us a talk. So my mom said, okay, let's put on the things, and had all this type of, a whole time he was there, we had given him fish. Salmon, cod, fish and brews, cod tongues, all this stuff. Now, my family are not a big fish eaters. So we weren't, my sister was biting her tongue about it. Anyway, Peter ate all this fish, even the herring. Now, if you know anything about herring, herring has about 1,000 bones in it. So I go up to London to visit Peter, and his girlfriend at the time, which is now his wife, says to me, you tried to kill him. He has a fear of fish. He thought I'd die from the bone. So anyway, without further ado, Peter's going to tell us all about asteroids. And I'm going to try to unmute myself, or mute myself so I can hear you guys. Take care. Take over, Peter.
Thank you very much, Gary. And of course, I anticipated that you had mentioned the story of my visit to St. John's back in 1978. That was great fun. It was my first time on the Rock, and I really appreciated your hospitality at the time. It was great. So I'm going to share my screen, and we'll try and get started here. All right, so
Go away.
how's that look? Is my screen on your screen, everybody? Sounds good.
Yep.
I've titled my talk, Assessing the Asteroid Threat. But actually, I do want to talk about a fair bit more than that. I'm going to talk about the small bodies in the solar system. There may be some folks joining us who want to have just a general overview, things like that. We'll talk about how the discovery of the solar system has led us to where we are today. There's lots of things on the planet Earth that we recognize as being examples of a threat of asteroids in the past. It wasn't always known that way, but we know it now. So we're going to talk a little bit about that, and I'll go through a few other topics as we go along as well. This photo is a fairly new photo. There is a comet in the night sky these days called Comet 2020 M3, and Greg Ruppel is an astrophotographer in Tucson, Arizona. One of the fun things that we've done in the last few years, I'm a retired college teacher, and so my wife and I have been spending the winters in Tucson, Arizona, so we get to join the Tucson Amateur Astronomical Association, and Greg is one of those. This is a photo he took within the last couple weeks. You'll also notice the credits at the bottom right of the screen. The comet was discovered by the Atlas survey, which we're going to be mentioning as we go along here. Now, I'm in a pretty good situation. I'm not a scientist. My math skills are not good enough to know what Chris's t-shirt says, but I sure wish they were, because I do love math. I love the math topics. I just wasn't able to do research at that level. So I'm what I think of as a wannabe scientist rather than a researcher. If science was rock concerts, I would be a groupie as well. I love going to scientific meetings. I love learning about the people behind things. And then, of course, I love sharing all of that with you. And in the current environment, I've been to St. John's a few times. This is my third time being your guest of honor as a speaker. And I promise that, that this is an advantage of this whole COVID situation. And I made myself a commitment. I'm not going to complain about COVID. I'm not going to make any COVID jokes as we go forward. Okay, so hold me to that, folks. So here we go. One of the things that is often discussed when people mention the threat from outer space, the disaster, the doom that can come from outer space, is that comets are also a threat to the Earth. And so I thought I would at least mention comets a few times. Here's a picture. Here's a page that has two pictures: comet on the left and the asteroid on the right. Most of you, I'm sure, will recognize the difference between them. But there's a couple of interesting things that I want to point out to you. First of all is the composition. Comets are mainly icy and asteroids are mainly rocky. In bygone times, folks thought these were completely two separate things, but now we recognize that every comet has a little bit of rocks mixed in with it, and pretty much every asteroid has a little bit of ice mixed in with it. So it's kind of a spectrum of objects, and we've seen objects that kind of fall in between. We're not going to worry about that here tonight. They all represent a threat, but there is there's some very important differences to the way we see comets in science and in our night sky. So on the left-hand side, the comet that you see there is the comet from this summer. One of the few really wonderful things about the year 2020 was Comet Neowise, or C2020 F3. And, we were able to see it for like 3 weeks. It was really a great opportunity. But what you're looking at when you see a picture like this, that photo covers many millions of kilometers of outer space. The comet is giving off all kinds of gases and things like that that are what we're looking at, that are visible to us. The comet itself, the actual object, is a very, very tiny object way down there. In fact, the center, not the center, but the sort of focus where all the action seems to be coming from in the comet photo is actually the coma, which is a cloud of gas and dust that's around the nucleus itself. The nucleus is pretty tiny, and it doesn't really even show in that photo. In fact, of course, the nucleus, if we could close up on it, it would look a little more like that asteroid on the right. The asteroid on the right is asteroid Bennu, which has been in the news lately because it's being visited by a spacecraft named OSIRIS-REx, and I'll have opportunity to say a few words about that a little later as well. And in fact, the size of asteroid Bennu is only about 600 meters across. It's one of the few asteroids that's almost evenly shaped. It looks like a more or less a round potato instead of an oblong shaped potato. And so that's 600 meters you're seeing on the right-hand side, is a completely out of scale with the thing that you see on the left-hand side. In fact, I kind of scrunched Bennu down there and put the little words not to scale, but even the scrunched down Bennu is still not to scale with the photo of the comet. So there are actually very few comets. A lot of folks tend to, not realize that really ever since we've been discovering them with telescopes, there have only been a few hundred comets discovered. Whereas in the case of asteroids, we know there are, quite a few of them, and in fact, we're up into the millions already. So that's one key difference. Another difference is their paths in the solar system. The comets tend to have very, very elongated orbits. Some are even parabolic in the sense that we don't expect them ever to come back on closed orbits ever again. Whereas asteroids tend to have orbits that are more or less circular. The E approximately 1 is the mathematical symbol for being very elongated or parabolic, and the E approximately equal to 0 is the mathematical symbol for a circular path or a circular orbit. And asteroids are much closer to that. They're not as close to perfect circles as the orbits of our planets are, but nonetheless, it's still a pretty big deal. We are going to talk a little bit about comets tonight, but in general, it's been realized that even though comets have hit the Earth in the past, and in fact, it's possible that all the water on planet Earth was brought here by comets in the history of the planet Earth, that they don't represent a major threat in the sense of a risk to the Earth right now. In fact, Mark Boslow, one of the scientists I know who works down in New Mexico at one of the NASA labs, he was quoted in an article that I was looking at today. He says, "I'm more worried about asteroids than I am comets because there are so many more asteroids. The likelihood of an impact from an asteroid is probably 100 times the likelihood of an impact from a comet of the same size." And when he says size in that sentence, he's referring to the actual size of the nucleus, not that great big huge long tail, of course. So there's a big difference there, and that'll explain why I'm focusing on asteroids here tonight instead of so much about comets. So this is the solar system we all know and love. This is what we see as home. There's a comet orbit showing up there. And, the planets that are in this diagram only go out to Jupiter. There was no need to show more. We all know about the planets. They've been observed and seen by humanity ever since time was recorded. Comets are much more rare, as I've mentioned. And, comets can be very dramatic in the night sky. So an awful lot of our cultural history has involved going zawi when we see a comet go across the sky. Asteroids were not known until much more recently. Asteroids, we had to wait until the telescope was invented before we could even have a chance to see them. So there weren't any asteroids discovered until the year 1801. In fact, so asteroids in the early years of the 19th century, the four largest asteroids were discovered pretty much right away after 1801. And then there was a bit of a hiatus, and the next asteroids weren't discovered until the middle of the 19th century. By the end of the 19th century, something like 500 asteroids were known. And into the 20th century, discovery ramped up. And through the 20th century, more and more discoveries were made to the point where there's something like about 5,000 were known by 1990. And that went to 50,000 very quickly. We're well over 500,000 now. In fact, I was almost going to say 5 million, but I don't think it's quite that much quite yet. Another aspect of this picture that we see in front of us is meteors, which of course are more local objects. Meteors are things that we see across our night sky. Folks often mention that at this moment because they think they've seen a meteor and they think it's part of the solar system, and they're right, of course. But it's only that a meteor is only seen when a part of the solar system comes close enough to the Earth to try and travel through our atmosphere. And I know that lots of folks are keen meteor observers. Then there's another flip side to that as well. If a meteor makes it through the Earth's atmosphere and lands on the Earth's surface, it's called a meteorite. And we've collected many thousands of those over the centuries. In fact, meteorites were known in ancient times, although, of course, it wasn't appreciated what their true nature was and where they came from. In fact, in the 19th century, there's a famous apocryphal, it turns out, story that Thomas Jefferson, having heard the story of a meteorite being picked up in New England, said that he would rather mistrust the professors who are Yankees rather than believe that rocks could fall from space. But in fact, rocks do fall from space. The latest news, of course, is that there's a new telescope going to be opened in another year or two called the Vera Rubin Observatory, VRO. And it's going to be a massive survey telescope that's going to look at the sky, the entire southern sky, and whatever part of the northern sky it can reach, roughly in every 3 days. So over its 10-year lifespan, they expect to take an entire picture of their sky 1,000 times. And they're able to get so many objects and make so many discoveries that they expect to pick up observations of 6 million asteroids, among all the other things. And many of those asteroids, of course, will already be known, but they will fill in a big gap there. So we're looking at basically the last stage of introductory discovery of the solar system here in the next few years, and with the Vera Rubin Observatory coming online. When you look at the diagram in front of you, I want to make sure you realize that those nice round circles that are there represent the paths of the planets, Jupiter and the other planets inside there. There are, in fact, just in case you were wondering, there are, in fact, no lines in space. The lines are just there in the diagram for me to help you out. And all those little dots are completely out of scale. So that when I say that the main asteroid belt is populated by all these dots there, the dots themselves are so tiny that if we were actually able to put our eyeball in some perspective where we'd see the solar system in this plan, we wouldn't be able to see the asteroids at all. They'd be much too tiny. So, but I'm going to give you an even more extreme version of that. Once again, let me remind you that in this animation, there are no lines in space. The circular lines that you're seeing represent the paths of the planets, and it's on a loop. So you can see it's really only a few seconds long. And every one of those dots represents a known asteroid. And this is actual data from observations as of just almost 2 years ago. I guess, no, almost 3 years ago now. Animation is really quite beautiful. And then once again, if we were able to stand back and look at all the asteroids from this perspective, we wouldn't see any of them. The dots way over represent their actual size. There's one other important thing on this diagram that we're going to be talking about here. The yellow dots, which you see more or less in an arc further out beyond the red orbit of Mars, that's the main belt of asteroids. All of the blue or turquoise dots represent asteroids whose orbits are a little more wonky. And even though it looks like there's plenty of them, it's only a tiny fraction of all the yellow ones. Those blue dots represent asteroids whose orbits at some point might intersect or cross the Earth's orbit. And so they're often called near-Earth objects. Some of them are ranked as being potentially hazardous asteroids. There's a bunch of different categories, which all kind of, makes an awful lot of fun and for folks to kind of follow up on. And of course, the researchers are constantly busy looking at all of this. Well, in fact, there's a hot news flash. If you didn't hear this weekend, let me be the first to fill you in. Last Friday, the Earth was visited by a small asteroid named 2020 VT4. Asteroids don't get nice sounding poetic names until long after they're originally discovered. And so in this day and age, of course, often asteroids make a splash in the news right away when they're discovered. So we have to talk about them with their temporary names, and that's what this is, 2020 VT4. So 2020 VT4 represents a very small object, probably only about 20 meters across. And in fact, it came closer to the Earth than any other object that we know of, other than the ones that actually did hit the Earth. So, and that was only just last Friday. The diagram that you're looking at is from the Jet Propulsion Laboratory's SSD website, Solar System Dynamics. You can go there yourself as a visitor and choose any one of the tens of thousands, hundreds of thousands of asteroids and have it show you the current location of that asteroid. And what I've done here is I've chosen to show a bunch of the planet orbits. You can see Mercury, Venus, Earth, and Mars. I didn't show the outer planets just because it would have thrown the scale of my diagram off. And the blue loop is the orbit of the Earth. The white arc represents the path of 2020 VT4. The vertical lines represent the fact that VT4 is above or below the orbit of the Earth at any point in time, other than, of course, last Friday. You can, in fact, see that where it says Earth in blue or turquoise, it's actually overwritten with the name of 2020 VT4. They're so close that the software couldn't, in fact, show the two names separately. And that's really quite dramatic. The discovery was made by with data taken from the Atlas survey instruments, which the main one is located on the Mauna Loa mountain on the main island of Hawaii. And one of the things I want to try and emphasize for you this evening is that there's a lot of opportunities for international cooperation. So the data from Atlas is immediately made available to collaborators all around the world. And Nick Erasmus was the first person who actually realized that 2020 VT4 was going to make this close pass. And he was doing that from his home in South Africa using the data. And he didn't actually realize it until after the Friday close approach. So 2020 VT4 approached within 374 kilometers of the surface of the Earth. So the distance from the center was only just a little bit more than the size of the Earth itself. And by the way, that's Nick in that slide down there. I had a chance to meet Nick a couple years ago, and we visited an observatory in Bavaria, and that's Nick talking to the director of the observatory there. So 2020 VT4 was in the news. This kind of thing has been happening a lot lately. In fact, it's almost getting to the point where close approaches of asteroids almost happen as often as meteors. And meteors are lovely things, of course. I wouldn't categorize them as a threat, but most folks enjoy seeing a meteor. You've probably had an opportunity to sit out under a dark sky on a lawn chair like this and look at a meteor at some point. Everybody likes meteors. In fact, I should also point out that if you've got clear skies wherever you are tonight, the Leonid meteor shower is this week. And in fact, you might be motivated to go and look for some even this evening. When the things land on the Earth, as I mentioned, they become known as meteorites. This is an example of a meteorite that fell in Canada on the 20th of November, 2008. So almost exactly 12 years ago. And right away, it was recognized by the data that was taken as the meteor was flashing across the sky, that there was a pretty good chance that some rocks would actually hit the ground. So a whole bunch of Canadian scientists raced out to Saskatchewan, started driving madly up and down the roads before the snow could possibly come and wipe out any sign of it. And here's Ellen Milley looking at the first of the actual meteorites that was found from this incident. They're all known as the Buzzard Coulee meteorites. And lucky for them all, it was cold, the ice was there, and the meteorite had landed on the ice just a month or two earlier, and no one had found it before. In fact, my understanding is no one had bothered to look really until the scientists said, let's go out and check this area. And since then, there have been more than 1,000 small pieces of the Buzzard Coulee meteorite found. So it's actually one of the best represented meteorites in the history of meteorite hunting. That's kind of a neat story. There's some interesting rules in Canada. If a meteorite falls on a lake or on water, then it's public property. The people who own the land next to the lake can't claim the meteorites that land in the water. And if the water happens to be frozen and you happen to walk out and pick it up, well, that's just your good fortune. So there you go. These meteorites, of course, are immediately turned over for scientific discussion. Of course, there are other examples. And when we're talking about threats, of course, this is a famous one that happened in 1992. Someone put a big car in there, put a car in their driveway, and that was hit by a meteorite. And the date of this was October the 9th, 1992. It happened to be a Friday evening. The weather was pleasant, and this was in the area near the city of Peekskill, New York. Well, it turns out that in the USA, they love to play high school football games on Friday evenings. So in fact, there were dozens of videos that were made by parents videoing their football playing family members, and they saw a bright flash in the sky and turned the camera up and caught a picture of the Peekskill meteorite. And these meteor videos were used by the scientists to calculate the orbit. Now, that doesn't seem like that long ago, 1992. But at that time, it was only the fourth example of a meteorite that had landed on the Earth. And then the scientists were able to calculate backwards where it came from in space. That makes it quite kind of interesting. Nowadays, of course, this is routinely done. And in fact, if we count meteor observations made by radar, then in fact, this is up in the millions now, because radar observations are able to pick up little tiny meteor particles that are only the size of a grain of sand, and this is happening all the time. There's a radar installation not too far from London here. That is the most powerful radar of that type, and it's used to, it's basically running 24/7 and observing meteors with the radar system. This car, by the way, this is a pretty famous case, of course. Michelle Knapp is the owner of this car. She heard a thump, went out and saw this rather funny dent in her trunk. She had paid $300 for this clunker of a car. She was able to sell the car as a curiosity item to meteorite collectors for $25,000. So a pretty good way to make a dollar on a car, but it doesn't happen all that often. The meteorite itself was sold for $50,000. That's fairly common that meteorites sell for good prices, by the way. Well, okay, let's talk about another kind of interesting example that happened not too long ago. This was in 2008 on October the 6th. This is the incident known as 2008 TC3. It's the first case where a meteor was discovered before it entered the Earth's atmosphere. And it was discovered by Richard Kowalski, and they recognized that it was coming in, but they only really discovered it just, a day or maybe 36 hours, not very long before the impact. So they didn't really have much time to think about it. This was the first case of this happening. Nowadays, of course, they do this again. They do this much more routinely, and it's happened quite a few times. This fellow, Peter Jedicke, who you see here in the photo, he went to the impact location, which was in the northern Sudan, so in Africa. And a bunch of students from a university in the Sudan were sent out to start looking for these things. And it being a nice dry area with level ground, they were able to pick up a bunch of fragments. And Peter Jedicke kind of comes across, to me anyway, as a bit of an Indiana Jones type. He likes to go on these gallivanting adventures and try and find meteorites and find stories about asteroids and so on. It's pretty neat stuff to think about. Let's talk about how the discoveries actually happen. So the discoveries nowadays are almost all done by dedicated surveys. In other words, somebody has installed a telescope, designed it specifically to do the job of looking for objects in the sky. They don't necessarily have to be large telescopes. Professional observatories use very fancy software to do this, so that the telescope is controlled and marches across the sky and does everything in a very routine way. But there are many amateurs who are also doing this as well. Tom Glinos, one of our RASC London Center members, is a Canadian example of this, who uses the telescope to make these discoveries. And of course, we're going to mention David Levy again a little later when we talk about comets as well. A lot of the success lately has come from the fact that there's really good data sharing going on with websites where both the observations are posted, and often automatically by the software connected to the telescopes. And also for the same reason, it's easy for other folks who want to analyze the data to access that data. You almost don't have to know each other. The person analyzing doesn't even necessarily have to know who made the discovery or who's doing the survey. They just need to know where to access the data. And that's a really positive thing, of course, in the way things work. The sort of classic way of making these observations was to do blinking, where you would take 2 or even more pictures. This is an example that I was able to take these pictures using a telescope on Haleakala, Hawaii, called the Fox telescope. It's a 2-meter telescope, and this is an asteroid known as 14941 Tom Swift. And I made these pictures on July 15th, 2010. And it's not exactly perfect the way the pictures are lined up, but you can probably see where you're, from your home screen, you can see the little dot in the lower right, not too far below the center, moving to the right, and it's on a loop, of course, again, so you can appreciate this. These loops like this, these little animations, are really just for entertainment. They're lots of fun to look at. The discoveries nowadays are done internally within the software. The software is so incredibly sophisticated nowadays that you can take a picture of a region of the sky, tell the software, how it was taken and so on. The software can figure out what part of the sky it's looking at, what objects should be there, and if an object isn't there, then the software will recognize that and report it pretty much immediately. Some very odd things happen. This is an asteroid known as 3753 Corinne, which is a Gaelic, I believe, or Welsh name. Folks have a hard time pronouncing it. I hope I did justice to it. I've been schooled in how to pronounce this name. The yellow squiggly line represents the orbit of this asteroid, and the blue line represents the path of the Earth. So you can see that it's kind of doing these strange spirally loops around the Earth. This is a good thing in a way. I mean, it's interesting that this kind of thing can happen, but it also tends to imply that there may be asteroids that kind of focus and come in almost as if they're zeroing in on us. And that, again, gives us pause to think about where the threat might actually come from. So let's just say a few more things in general about asteroids. This is a photo of asteroid 243 Eta that was taken in 1993 by the Galileo spacecraft. It was one of the early examples of a spacecraft visiting an asteroid. Now, once again, we're getting used to this. And I've put this picture on the same scale as a map of the city of London here where I live. And just to give you a sense of how big these things are. So this is not one of the smaller asteroids. It's 56 kilometers long and about 24, 25 kilometers wide. And when Galileo, the spacecraft, came towards it, one of the photographs they took showed a smaller asteroid next to it. In fact, Eta was the first asteroid discovered to have a satellite or a moon of its own. And even the tiny little companion asteroid is bigger than most of the asteroids that we will talk about when we talk about them coming frequently past the Earth. That's an interesting sort of thing to have happen. In fact, so the companion is named Dactyl, and it's about 1,400 meters across. That would fit on our threatening scale if it was on its own, and if it was on an orbit that was going to threaten the Earth. So we need to keep the size scales in perspective. And here's a way of doing that. All the variety of different asteroid sizes is all shown in this diagram. At the top left are the bigger ones, and you see two sort of colored discs for each entry on the graph there. The lighter color is an individual asteroid, representative, or the only one in the case of the top left there, whereas the darker band is what the size would be if all the asteroids that are that size could be gathered up together into one. So you can see that down the chart, there are enough asteroids of the smaller size so that the total amount of material is roughly the same as the one really big asteroid that we know of, that's the biggest asteroid, which of course is #1 Ceres. You see its name up there in the top right of the screen. So we have to think about the asteroid threat as a question of different sizes, going from very few large objects all the way down to very, very many much smaller objects. Now, this diagram is referring to the asteroids in the main belt. These are not all the asteroids that threaten the Earth. We will talk about those in a minute or two as well. When folks ask what's the worst that can happen, often this picture comes up. This is Meteor Crater in Arizona. It's by no means the only one. We know of something like about 200 places on the Earth where we have clear evidence that a meteorite big enough to leave a mark has hit the Earth. This is a fairly recent one, 50,000 years ago. The object that came in was about 50 meters across. So again, try and keep this in perspective, comparing that to Dactyl, the companion of the more or less average size asteroid. Dactyl was only 1,400 meters across. This is only 50 meters across. So it's pretty tiny by those scales. It was made of fairly solid material, nickel iron, and so that meant that it made a really, a strong impact. And 50,000 years might seem like a long time to you and me and the human race and our civilization, but it's not much in geological time. One of the cool things about Meteor Crater, of course, being in the USA, it gets an awful lot of attention, and for the last 100 years, it's something that amateur astronomers have always been, aware of. But you can actually go and visit there. There's a visitor center on the lip. You can kind of see the road snaking its way up there, and the visitor center's right there. You can actually visit. They don't let you climb down inside, at least not on a regular basis. But I do know, some of our scientist friends, you probably know them as well, have been down there visiting. Of course, the most famous one of the folks that we know is Gene Shoemaker, who was a geologist involved with the Apollo program back in the 1960s. And he was one of the first persons to actually look closely enough at the rocks to draw some conclusions about that. A much bigger example was the Tunguska event. This happened in our own historic times in June of 1908, but it happened in such a remote corner of Siberia that even though there was evidence from the seismometers way far away in Europe that something had happened that day, no one was able to go out. It's just too remote out there until decades later. And even today, it's not a frequently visited place. We now know that there isn't an actual specific crater like the Arizona example. So what scientists think is that something exploded in the atmosphere, and that's also important to our topic because that's another way that the threat can present itself to us here on Earth. And anyway, it took decades before remember, at that time, 1908, Russia was still in a czarist political situation, and that all changed after World War I. By the time the Soviet Union got its scientific act together enough to send a team out there, like I say, a long time had passed. But it's still mentioned frequently as, the best example of a recent, major disaster that an asteroid caused. And in fact, of course, nowadays, for the last 12 years or so, every year on the 30th of June, the outreach departments of a lot of these institutes and research places sponsor an asteroid day in honor of this event. So it's a big deal for us still to this day. Now, this next one is maybe the biggest one of all, and this is an animation. I'm going to push play here. And it's got the lines, of course. I keep saying this. Remember, there's no lines in space. You see the Earth going around. The size is completely wonky. The Earth isn't really that big. The red oval represents the motion of an object, which we're going to see shortly. There's the Earth going around again. Every loop is 1 year. And look on that red oval. You see a red dot, which is speeding up, and all of a sudden, kabang. Well, that happened on the 15th of February in 2013, so only just a very short while ago. And here's what it looked like if you were driving a car and maybe just a little oblivious to what's happening in the sky. I'm going to run this one as well. It's only a short one. Turn your volume down if you don't like crazy music. The asteroid did not cause the music. Wow. You can see the trail lasted in the sky for quite a long time after the actual explosion of the object occurred. One of the fun things that happened there was that quite a few of the folks who observed that just merrily went on their way as if nothing was going on. The danger doesn't seem to matter much to human beings, I guess. So that occurred over Russia, a fairly remote part of Russia, except that there's a big city there named Chelyabinsk. The incoming object, something around 17 to 20 meters in size, made an explosion, not a single point explosion, but an explosion that created a cylinder of explosion as it went along. And that's what you saw, the trail there. Total equivalent of something like 500 kilotons of TNT. It's not really fair to compare it directly to a nuclear explosion, but it's certainly of the same basic size. Now, of all the things that the scientists have found in the 100 and change years since Tunguska, the Chelyabinsk event is the strongest explosion, and it's also the best well-documented example of a big event. 432 separate videos were analyzed to calculate its orbit and the strength of the explosion. Many of those videos came from dash cams, just like the one that I just showed you. Now, partly because of what happened at Chelyabinsk, there's been a kind of a shift. And part of the reason why I chose my title tonight is because of this. It's really quite a significant thing that folks have kind of come up with. In fact, there were no fatalities. Nobody was actually struck in the noggin by a chunk of meteorite. No injuries that way. But the explosion damaged something like 1/8 of all the windows in the region around Chelyabinsk. Chelyabinsk is a city about the size of Edmonton. Now, you think about that, an event that can break that many windows, my goodness. It blew a roof off one building. This is just from the shock wave, not the impact of the rocks itself. So something like that's estimated $33 million in damage was caused by this. That gets folks' attention, even though no one was killed. The shock wave, mainly the broken glass, caused something like 1,000 folks to go to hospital and say, I've been injured by the broken glass. It's really quite a scary thing. So, in fact, the idea that a smaller object could cause a noticeable, but not, global scale kind of a catastrophe is something that's really been quite interesting to folks lately. And so that's where it kind of goes. In fact, one of the things I find funny about this is they had to cancel the hockey game at the local arena. This is the Chelyabinsk Traktor, the home team there. And a day or two after the event, a Canadian goalie playing for the Chelyabinsk team was interviewed on the CBC. And it was pretty funny listening to them talk about how, strange it was that a hockey game would be canceled by an asteroid impact. I think that's pretty rare in itself. So, based on the statistics of objects like Chelyabinsk and the other events that have happened in the last few years, the scientists have pretty much come to the conclusion that there may be many more of these smaller objects than the original projections may have. Remember, the original, from 100 years ago, all we saw was big objects. Now we're starting to see more and more of the smaller ones. And as we fill in the statistics, we're starting to realize there's more of them. So events like Chelyabinsk that are not as destructive as wiping out an entire city or killing thousands or hundreds of thousands of citizens, those events might actually be frequent enough that we want to factor in those kind of possibilities for damage and possibly have a warning system, of course. That would be kind of a nice idea. Scientists love charts. Here's a chart that kind of shows how the various sizes and so on fit together. It's quite frequent. Quite often you see diagrams like this. I'll show a couple more, in fact, in a couple minutes. Along the x-axis, the horizontal part of your screen, is either the size or the explosive strength of the asteroid. So we're talking about equivalent tons of dynamite. There's 100 in the middle. You see Tunguska about 100, and you see 1,000,000 global catastrophe. The one over on the far right, the 100 million tons of dynamite, that's called the KT extinction. That was the event that took place 65 million years ago, which we're fairly certain, scientists are pretty much positive about this, led to the demise of extinction of the dinosaurs. So it's pretty cool. On the left-hand side, going up vertically on the y-axis of the screen, you see the frequency. How often do events like this happen? Well, the KT extinction event only happens, once or twice in 1 billion years. Do we need to worry about it? You choose. But events that happen every year or every century, once every 100 years or so, and cause a lesser amount of damage, but still something worth thinking about. That's what this is about. In fact, here's a chart of extinction events. This is a really old graph. I can't even remember where I originally sourced this graph from, but the white line represents extinctions as calculated by biologists based on the fossil record. And you can see the peaks are times in the past. Time is going forward to the right, 500 million years ago to now. And you can see there are five colored bands, each of which represents a known major asteroid impact. And it almost perfectly lines up with 4 of the big extinction events. So that's a rather interesting thing, but it only happens every few times, maybe in 1 billion years. Would you worry about it? Well, the public is not really going to worry about that too much. The public, of course, does get excited when things happen in science, but it has to be something happening like now. Shoemaker-Levy 9 was an example of a comet. I said I would come back and mention comets a couple times. This is one. It hit the planet Jupiter in 1994. I think probably many of us who are paying attention right now are old enough to remember it. It's funny sometimes talking to young folks who read this in books and think of it as ancient history. But all of the impacts of the comets of Shoemaker-Levy 9 were pretty major events. And they caused a kind of a cultural shift and awareness that this kind of thing really can happen. You know, if you had mentioned 30, 40, 50 years ago, the idea of, asteroids hitting the Earth, folks might have laughed a little. Well, David Levy was quoted as saying after Shoemaker-Levy 9, the giggling was over. People started to really think about it as something quite serious. So let's focus in now on those asteroids that were represented with the turquoise dots in that animation I showed a while back. They are the near-Earth asteroids, and as our technology and telescopes have paid more attention to them, we get more and more of them. So never mind the rest of the asteroids, the millions of asteroids out there in the asteroid belt that are the size of Ida or something like that. Let's look only at the ones that might be in the neighborhood of the Earth, and you can see how many of them we've discovered since 1995. It grows and grows every year. I get a kick sometimes out of the colors here because there's a sort of a friendly competition among the various surveys, and you can just look at the colors and see which survey kind of was winning the competition for a while. It usually represents some kind of a technology upgrade when one survey supplants another as the leader in this. And by the way, if you look at the far right, the 2018 column in the histogram here, is only halfway up. That's not because there were fewer of them discovered. It's because the chart was based on data that stopped on June 5th of 2018. That's when I was able to pick up this graph from a conference that we were attending. So this gives you a sense that there's lots more of these things coming. And here are the sizes, as far as they are estimated, of those objects. And this is slightly newer data, just a year old now. You can see the numbers at the top of each of these bars represents how many near-Earth asteroids are thought to be in each of those categories, size categories. So between 0 and 30 meters, these are things like 2020 VT4. We've got under 5,000. Between 30 and 100 meters, more. Between 100 and 300, between 300 and 1,000 meters, and more than 1,000 meters. Now, the ones that are more than 1,000 meters are big enough to qualify as regular asteroids, really. And the astronomers have made a big effort to try and find all of them. The so-called Space Guard survey, which was started back in 1992, tried to find all of them. Here's the same information, really, but done as a pie chart, showing how between 2010 and 2018, we've chiseled away at finding the number that are predicted or calculated to exist out there. We don't know that there's that many out there, but we suspect all the ones that are in white are ones that have not yet been found. So the red ones are big ones that have been found already. We found almost all of those. The yellow ones are in a slightly smaller size range, and then the blue ones are the ones in the size range under 300 meters. So you can see we're building up our statistics, and that's important by itself, knowing what sort of numbers there are. All of this has led to some sort of awareness of the threat. And the Torino scale, which is this chart here, is a bunch of numbers where the asteroid threat would be represented on a scale of 1 to 10 or 0 to 10, 0 being no threat whatsoever. I'm showing this with a little bit of trepidation because after it was announced, quite a few asteroids were discovered that fed into category 1 or threat number 1. And, people started saying, oh, well, there's a threat. But of course, it's not really a threat when it's only a 1 on the scale. And one of the things that the scientists agreed to do is they agreed to only discuss the threat within the next, say, 100 or so years, something that's going to hit the Earth. Even if we knew for certain that an asteroid was going to hit the Earth 1,000 years from now, would anybody really care about that in terms of, public policy or so on? So the really big thing that you want to take away from my lecture this evening is that the it's not just the drama of an asteroid hitting, it's the concept of risk. How much damage is done compared with how often the disaster occurs. A frequent event that has less damage might still be something to worry about. So here's my example of a car crash that wipes out a lot of cars, but happens less frequently. Do you worry about that, or do you worry about the smaller impacts that are involve only just a few cars at a time, like two? And of course, we worry about impacts that involve two cars at a time. It happens all the time. There's an awful lot of factors involved. With cars, we tend to take a lot of things for granted, but with asteroids, you have to lay those things all out very carefully. How many deaths would you trade off for how many injuries? How much property damage would you be willing to accept in order to avoid a single death or a certain number of deaths? Those are the balances we have to have. This chart shows the same information as I had before, how many of them there are versus how energetic or how disastrous they are. And you can see the chart more or less goes on a nice diagonal line. The zone that's been getting folks' attention is the upper left, where you have lots and lots of objects, but they're very, very small, so they hit fairly often. They don't cause a tremendous global disaster, but they still cause damage. And that's interesting because the red line, which you'll notice goes well below the diagonal line, those are the ones that are actually discovered. So there's a huge number of small asteroids that nevertheless are worth worrying about, that still lie out there and need to be discovered. One of the things that we need to know about is the makeup of these asteroids. Are they really solid, made out of like metal, or are they kind of loose? And so there's this spacecraft that just put its leg down on the asteroid Bennu just last month and gathered up some material. Bringing that material back to Earth, of course, is very helpful, because then we can try and compare our observing data with the actual makeup of the asteroids. We need to know, especially for these smaller asteroids, we need to know what they're made out of so that we'll know how they will behave if they enter the Earth's atmosphere. And now, just to throw one last topic in, there is also the positive side of this, that these asteroids do represent a resource. The asteroids that are out in the main belt are very difficult to get to. You know, this year we've seen in the news a couple of spacecraft on the way to Mars. Well, think how much harder it would be to go even out to the asteroid belt to try and get to those bigger asteroids. But the asteroids that are close to the Earth, that represent a threat in one way, represent a resource that could be reached without perhaps too much energy or effort. And so, for example, a company named TransAstra has made this proposal here that they're going to make a model of. They want to actually build a factory spacecraft that will put a bag around a small asteroid and then use solar energy to evaporate all the water that's chemically bound up in the rocks of the asteroid. And of course, the water represents a resource. In fact, they've actually got a proposal. They're building a small version of their factory spacecraft, and they're actually building a fake synthetic asteroid. And they want to launch the two together and demonstrate that the spacecraft can actually build a bag around the small fake asteroid and then actually work it out in space. The fake asteroid, of course, we'll know exactly what it's made of because we made it that way. And so the factory spacecraft will do that. If this is on the verge of being funded, so we may hear about this project in the not too distant future. And we're going to go on there. That's all I'm going to say for tonight. I thank you for your attention. I'm here to answer your questions if you have any. So I'll turn it back over to you guys, Randy and Gary and Mike and Chris.
Thanks
Peter.
very much.
Great. Excellent.
So is Chris watching the questions or me?
I've answered a couple while the talk was happening.
Yeah.
Um,
There was one from Walter McDonald asking if a meteorite or if an object hits a car and doesn't make it to the ground, does it still count as a meteorite?
Figures Walter would ask that, but yes, of course it does. I'm sure it'll reach the ground when someone picks it up.
Okay. And Chris answered one already. Would you say that meteorites are indeed asteroids that hit us? There's only a size of difference. That was from Martin Rice, but Chris
Yeah,
answered
I
that.
think that's fair to say. I mean, you know, partly it's historical that we use these particular this particular terminology has become popular. But yeah, in a way, even when we think of the little tiny particles that are measured by the radar instruments, for instance, you know, they're only, you know, size of a grain of sand. They're never going to make it down to the Earth's surface, but they're still important to study for for scientific purposes, and they're still meteors. A meteor is any phenomenon that we see in the atmosphere above us due to an object coming in from outer space.
Okay, there's a question here from John Peddle. Asteroid Apophis is changing its orbit slightly due to heating from the sun. How long before we can tell if it's more or less of a threat?
Not a bad question at all. The threats, of course, are constantly being reevaluated. And Apophis is famous, I've forgotten the details, but Apophis is famous because it's one of the few examples where an actual calculation showed that there was, you know, not a small probability. Most of the time they do the calculations, and even if they do the calculations for 100 or 1,000 years in the future, the probability comes up as being, you know, 0.00001 chance that it'll hit the Earth. Well, Apophis was one of the few examples where the probability of the calculation was actually not so tiny. But they went back again later with more observations, and they realized that the incident they were predicting wasn't actually going to happen that way after all. So you have to constantly reevaluate these things, and particularly because of effects like heating and, of course, the gravitational effect of things going by and so on.
Okay, I don't see any more. I've got a question myself.
Sure, Mike.
So, and one difference between comets and asteroids is the orbit, and I would think that a comet's coming in with a lot more kinetic energy, just because it's got, you know, especially if it's in a very elongated orbit. Is that an issue?
Yes, it is. Comets, not only can comets be going actually faster than asteroids, there's quite a variation, of course, and overlap in terms of speed, but often it happens that comets are coming in reverse orbits. So with a comet, it's much more likely that we're going to hit it head on. Asteroids often will kind of come up on us from the side, or, you know, so a comet that hits us head on, to calculate the amount of energy in the collision, you could add up our speed plus their speed, and that would make it quite significant. But again, those are very rare events.
Mark Pippi asks a question, and a sort of a fun question. What is the probability of being killed by an asteroid or a meteorite, I guess, because it flies.
Well, you know, it's a fun calculation to do. I think I actually remember doing that calculation back in my university days. You know, you take what you figure the average size of a human being is. What are you, you know, a tenth of a square meter or something like that. Add up we got, you know, 7 billion human beings on this planet. Multiply that, figure out what area of the Earth's surface is actually covered by honest to goodness human beings. And then just figure out the fraction of the total surface area of the Earth. And then you can figure out the probability of that. You know, to be serious about it, of course, no one has ever been killed directly by a meteorite impact.
One person's been hit.
Certainly that we know of, anyway. But there have been a couple of cases where persons have been hit. The one that I'm thinking of was kind of indirect, in the sense that it was a woman who was sitting in her living room, and a meteorite hit her house and fell vertically down from the roof and landed on her thigh. You know, it's bound to happen sooner or later. We have a case in Canada here. There was a person playing golf at a golf course near Kitchener, Ontario, which is only not far from London. And they kind of heard a sort of a whistling sound and heard a thump. And not too far away from them, they saw this hole in the ground, and they went over, and sure enough, by golly, there was a meteorite that had hit right there. Very unlikely event, especially on a golf course.
I have a question, Peter. I don't know if you can answer it, or maybe somebody across the country can. Are there any observatories now in Canada searching for meteorites, killer asteroids? There used to be one in Calgary, and I remember Victoria or Victoria used to.
The telescopes, most telescopes that can do this work are at least, aware of what they are capable of doing, Gary, as I'm sure you appreciate. There aren't that many telescopes in Canada, of course, but, we think of our friend Dave Lane down in Halifax, who's running that VGO with remote operations. So you can, Twitter into his account there and command the telescope to take a picture. I'm sure that if they were to find a streak across one of their images, they would investigate. And if it turned out to be a new asteroid, they'd be more than happy to discover it. Now, I'm not aware of any recent discoveries, especially not in this sort of fast response world where we're thinking of events like the one that happened last Friday, where you got to be on the ball so quickly. I don't know of any. I don't think there's any Canadian observatories that are set up in an with automated software to instantly report a discovery as it happens, so to speak. But we do have some Canadians who are involved in other projects. I mentioned Tom Glinos, whose telescope down in Arizona he was using. I don't think Tom I don't think Tom's on the call. Is he? If he is, he can answer. But well, I don't think Tom was set up so that the search routine was automatic. But he did have it set up so that when he discovered something, he would notice it, like he would be told by the computer. So it wasn't searching automatically, but when it just happened to pick up something, he would get notified. And like I say, there's plenty of other examples of Canadians who are studying this. Here in London, we've got Western University and the Institute for Earth and Space Exploration. They're involved with this all the time. Paul Wiegert, whose name you might have seen on a couple of the animations that I showed. Paul did, for instance, he did a search through legacy data from the Canada, France, Hawaii telescope, looking for asteroids that had not been spotted in the data before. So that sort of thing happens. Canadian researchers are active in that all the time. And I think you folks mentioned to me that Phil McCausland has taken a new role in your club, and I think I saw Phil's name on the list of participants. So hello to Phil, and he certainly qualifies as a researcher in this field. There's Phil saying kaboom, you bet. Thanks for being here, Phil. Nice to have you.
There's another question here from Jim Johnson. Is there any naturally occurring radioactive material associated with meteorites?
Hey, I didn't think about that, but sure, there's a good question, and the answer is yes, of course. Radioactivity is present in pretty much all matter, and in particular, when we investigate a meteorite in the laboratory, it's very interesting to pick out radioactive isotopes, because the half-lives of the radioactive isotopes can tell you some very important details about the age of the meteorite and what may have happened to it at some, long time in the past, maybe billions of years in the past. So yeah, the radioactivity is there, and it's definitely something the scientists are set up to measure. However, I want to hastily point out that it's at an extremely low level. Nobody is suggesting that an asteroid could be mined for, nuclear, fissile, dangerous kind of fuel. There just isn't enough of that, probably anywhere in the asteroid. You'd have to mine so large of a quantity of asteroid ore that you couldn't possibly get enough out to make it worth your while.
That all our questions?
Can I ask one more?
Yep.
Sure.
Your Welsh thing that was looping around. So I mean, is that in orbit around the Earth, or is it, how closely associated is it with? I'm trying to understand that motion, how that works.
Yeah, I would love to be able to understand it, and I don't. Paul Wiegert is the fellow who unraveled the story of asteroid Kruinia, and we could ask Paul sometime to try and explain that. I've actually heard Paul explain it, and I've heard a couple of other researchers explain it. The orbit is not technically an orbit around the Earth. It's still orbiting the sun, but its orbit is so locked to the Earth's orbit that from our position, as we go around the sun, looking out at Kruinia, we see it going around us. There's a family of different mathematical curves that fit that possibility. And some of them have rather interesting sort of back and forth shapes. So that if you could stand, let's say if you could stand at the center, if we could stand where the Earth is, and without, you know, turning 24 hours a day, just look out and see this thing going back and forth. It would have a kind of an interesting back and forth motion across the sky.
Okay.
Some of them will loop all the way around and then reverse and come all the way back. But it only appears that way because they are going around with us as we go around the sun. So it's our point of view that makes it seem so peculiar.
I want to
Okay,
say
thanks.
Lisa Zhu figures. There have been articles recently about very small moons, second moons, that the Earth picks up, but only temporarily.
Yes, the so-called mini moons.
Yeah.
And you guys might recognize the name of one of the key researchers who's worked on calculating the statistics and predicting that, because his name is Robert Jedicke. And so they don't have any known observation yet that is guaranteed to be proven to be a mini moon. But there have been a couple of cases of things where they thought that they had found something like that. Robert's calculations show that on average, there will be a few of these mini moons captured and then ejected afterwards. Yes, Marty Rice, my friend Marty Rice from Pennsylvania, is pointing out that I gave a talk about the mini moons to the group at the Adirondack Astronomy Retreat a couple of years ago. That's where Marty and I know each other from.
Any other questions before we thank Peter?
Well, there's one more just came in from Robert.
Okay.
Is there an asteroid in the belt that is theorized to be the makings of the core of a planetesimal?
I think the answer is yes. It's a really complicated topic for me because I don't know much about geology and I can never keep all these categories straight, but I find it really fascinating. One of the slides, I don't think I mentioned it, but the Vera Rubin Observatory, the director, Stephen Kahn, gave a Zoom presentation just last night, so 24 hours ago. And he talked about all the different things that the VRO is expecting to discover. But when he got to talk about asteroids, he showed an interesting graph where he had, you know, basically all the, let's say, 1 million asteroids that we know about, all shown on this one graph, but they were color-coded according to what the calculations show their orbits all had a common point in the past. And there's only something like about 8 different colors. So all of the millions of asteroids that are out there might in fact stem from as small a number as perhaps 8 individual mini planets, you know, that started 1 billion years ago, that settled in after the formation of the solar system. And that what we currently see is the result of collisions and breaking apart of those 8 mini planets. I'm not sure I'm understanding that correctly, but that's what it sort of sounded like he was saying to me, and I have heard that in other contexts before. So that's kind of a neat idea. I mean, I think when I was a young space cadet, I thought I understood that the asteroids form individually as small little objects. But apparently that's not the case for at least almost all of them.
Got you all talked out, Peter. That's hard to do. I think.
There's Phil. Phil just pointed out to me that, or to us all, that the asteroid Psyche is thought to possibly be the core of something like that. As I was just trying to answer, I had heard that, but I'd forgotten that for a moment. Thanks, Phil, for reminding me.
Yeah, Psyche made the media the last week or so as being this large chunk of iron nickel with very little rock on it. And I know it was Business Weekly or something. I don't think they're seriously planning on mining it for riches.
Well, again, my last slide about the in-space resource utilization kind of tried to address that. You know, and a mission to mine asteroid Psyche would be terrifically expensive. Take a huge, complex technology to do. And, you know, obviously, yeah, if Psyche's made out of all that metal, maybe you could get your money back. But it's a huge, huge risk. Whereas what TransAlta Asteroid is proposing is much simpler and much less expensive of an investment, and so has a much greater chance of, you know, turning somebody who's already wealthy enough to make the investment into a billionaire.
Well, Peter, I
Thank
have
you,
to
Peter.
say you've one of the few that gave us a lot more questions coming to you back to you. And I'm sorry about losing my sound because it sort of threw me off. But don't your family have an asteroid named after you? And
Yes, we do. Asteroid 5899 Jedicke.
Is that one of these asteroidsorus.com things, or?
Well, careful what you say, Randy.
No, it's legit.
Since we're among friends here, I really hope nobody's listening who would think of that. But you know, I'm always appalled when I hear about these shyster companies selling star names.
Yeah.
And I'm just really glad nobody has thought to do it for asteroids yet.
So next on the agenda, I had Gary Christmas gifts. I wanted to put in a plug for the National RESC.ca website. COVID-19 has caused both a manufacturing problem and also a run on, especially lower end beginners telescopes and equipment. And we're getting pretty close to Christmas now if anybody is looking to order anything. The RESC certainly would have some items that you might be interested in. For example, an amazing gift would be a membership gift to somebody. And you can get that on the e-store at the RESC.ca website. There's also this year a new almanac. I'm excited to get a copy of that. Handbook, calendars, again, you can order that all. I'd order it pretty soon if you want to get anything. I've been looking on like ConScope and All-Star Telescope, and day by day stuff is coming and going. So if you are thinking of ordering anything, especially the lower end equipment, it might be worth to call those sites and see if they actually have the equipment, because sometimes, you know, they don't update their websites all that frequently, and you certainly don't want to be disappointed. I haven't seen any scopes here at Costco yet this year, so I don't know whether they'll bring anything in this year or not. So I don't know if anybody else had any items they have seen around town that might be worthy of gifts or whatever. For binoculars are always a good choice, and as I said, publications from the RESC are always worth it.
yeah, I see our members, as soon as you started to ask for gifts, they started to hide on us. Yeah, that's very good, Randy. I haven't seen anything local this year. Well, because of the pandemic, I guess people haven't brought in hardly anything. And like you said, most of the bigger stores seem to be all selling out.
Yep. I've had a couple of queries just this week, even people wanting to buy something for a 12-year-old that sort of thing. And it's a lot of competition in that space. And even if you're thinking of ordering something from Amazon these days, if it's coming from China, unless you're willing to pay big bucks to get it quick, was it 37, 38 days of Christmas now?
Okay. You want to move on to the next subject, next item,
Mhm.
which is
Sky this month, or did you want to do member
let's do
member photos and stuff?
let's do member photos first, I guess.
Okay.
I don't know if Nikolai is there. He's got everything turned off, so he may
Oh,
be
there
listening.
he
Oh,
is.
there he is. You want to go ahead, Nikolai?
Can you see this?
Mm-hmm. Yes.
All right. So, okay. I did prepare this last night at 4 a.m. So if you see something odd or missing, please let me know. I won't be offended. So this is what you can see in the night sky from St. John's over the next month or so. As you know, this is available on our website and it's updated monthly. And the one for November and December is here. And what we have on the first page here is sun-related phenomena, so twilights and whatnot. Sunrise is at 7:11 and sunset is at 4:20. So that's a pretty short day, which is bad, but it's good because it's a pretty long night for astronomy. So that's that. There are the rise and set times for planets in the solar system right here. And then there is today's picture of the sun, which does have a sunspot on it in the lower left corner here. If you can see it, it's just emerging from behind, I guess, the solar disk, and it should be moving into view and becoming better positioned if it kind of sustains itself. So that would be something to look forward to. Yeah, of course, don't look at the sun without proper filters, and only, do it if you know what you're doing, if you've done your research. In terms of planets, this is actually, yes, we do have Mars, which reached opposition just over a month ago. So it's still very well placed for observing, but with how quickly Earth races away from it, it's dropping in size and brightness pretty quickly. So the earlier you look at it, the better. But like I said, right now it's still very well placed for observing. Its diameter will be dropping from 14.6 arc seconds to 10.5 through December. So, and 10 is generally considered to be the kind of informal threshold for observing Mars. As soon as it gets below that, it's you can't really get too much. Then we have Uranus and Neptune, the ice giants, which are still pretty well positioned due to their recent oppositions. And also in the evening, we have Jupiter and Saturn, which rise about 3.5 hours, or set 3.5 hours after the sun at the beginning of December, and closer to 2 hours at the end of December. And here in yellow, I have highlighted a very rare event, which will occur on December 21st. And on that date, the two planets will only be 6 arc minutes apart, meaning that you'll be able to fit both within the same moderate magnification eyepiece, which is tremendous. And the last time they were this close was in 1226. So mark your calendars. That'll be pretty cool. Morning planets, we have Venus and Mercury. Mercury is pretty good right now. in the morning sky, but it's kind of dropping as we go into early December and then becomes not observable. And Venus, of course, rising 2 hours before the sun at the beginning of December. So it's a prominent morning star with a waxing gibbous phase right now. All right, comets. I directly copied this without much opportunity to do research on the actual comets and to see, but just from a quick glance, I didn't see anything too spectacular. If you've heard otherwise, please let me know. Asteroids. These are the 5 most prominent asteroids right now, with the time listed for observation. Supernovae. I don't think there's anything right now, but here is the link if you want it. Meteor showers, of course. We talked about the Leonids, and there's the Andromedid, which is November 25th through 27th. And of course, the big one, and well, the biggest one of the year, the Geminids, which will be on December 13th. The night of December 13th into the 14th is when the peak will occur. And this year should be especially good because it occurs very close to a new moon. And projections are even pretty good, even not considering the moon. So definitely mark your calendars for that one. The peak should be kind of like, there should be a period of 8 hours before and after the peak. And with the timing that it's occurring, pretty much the whole night should be, really good. I've heard projections of up to 150 meteors per minute. No, not minute, hour. So that's 2 per minute. So it's really good. And moving on to deep sky objects, here is a list of what you can see. November and December, and these are essentially the deep sky objects that are high in the sky and well positioned for observing, both for telescope and binocular observing. Here's the International Space Station, lots of passes. Looks like early evening is when they are in the east, southeast, and then in the northwest. As you go into December, observing sessions, none right now. And this is your observing calendar. This is this month, and then next month. We do have the 2 meteor showers, and we do have the monthly meeting on the 16th. So that's all I have. Are there any questions?
Oh, don't look to be. Thanks very much, Nikolai. Great for preparing that for us.
You're welcome.
Thank you very much. Okay. Okay.
Remember observing in photos.
Okay. Remember observing in photos. Okay. Let's see. Okay. This is Susan's picture, and I was going to have her.
Yes, I'm here.
Okay.
Can you hear me?
Yes, we can.
Oh, okay. All right. Well, I can't really say much more than's on the screen there, but briefly, this was a short hike to the end of North Head, Cape Spear. This was last Friday, and I reckon this shot was taken about 2:30 in the afternoon. So it wasn't really sunset, but you can see the angle of the sun. And on the way, there was just, the whole horizon was just like a mirror, a giant mirror. It was very, very beautiful. But that's what we saw when we got at the end. I didn't think I'd be able to capture it at all because I was taking the photograph directly into the sun. But this is how it came out. And it's just with my cell phone. So, no special equipment. But I thought it was really rather lovely. And unusual to see that track with the sun like that on the water. I've seen it with the moon, but not very often like that with the sun.
Very beautiful. Thank you, Sue.
You're welcome.
I guess it's usually a lot more diffuse and spread out and bright. And this one was really focused.
Is Mike there? Mike's gone. Oh, okay.
I
Go ahead.
Hey, oh, can you hear me?
Yeah.
Yes.
Oh, because I'm having some trouble here, but yeah, it was just another shot of Mars. In fact, I can barely see it right now because of my screen, but you know, it's one of, this was as Mars was starting to get a little bit smaller. You know, I could see the ice cap. It's with an 8-inch Daub, so it's sort of trying to follow it video with about 800 frames.
Okay, thanks, Mike.
Yeah.
Okay, this is a picture I took on November the 6th. You can see the polar cap. You can see some cloud, the polar cap, the polar hood, the northern polar hood, and some cloud on both sides here. Lots of detail these days. And Chris, they don't want, oh, right. Chris has a sore throat. I forgot that. He took this on November the 10th.
No, I'm here.
Okay.
Sorry if you've been wondering why my video keeps going in and out. It's because I turn it off every time I need to cough. Anyway, I'm good now. November 10th. Yeah, we've all been taking lots and lots of pictures of Mars. The details are there. I've got a 12-inch telescope and a little observatory out the backyard. I get out into it whenever I can. The trick to taking pictures like this, as others here will tell you, is take video rates, frame rates as fast as you can, 50 to 80 frames a second. Shoot for a minute or two or three, thousands and thousands of frames, and run them through software, which picks up only the very good ones, and then adds them up. There's still luck involved. The seeing in St. John's is not so great, especially if you're surrounded by houses with furnaces and dryers and cars. We're onto the jet stream, but hey, I'm happy to get this kind of detail. And that's basically it. I'll keep taking pictures until Mars shrinks to 10 arc seconds.
Okay, thank you, Mike.
Thanks.
Jim.
Hello.
Okay. We can hear you, Jim.
Oh, perfect. Yeah, so these couple images I just captured, I believe they were on the night of November the 8th. Never had a lot of time. I don't think it was clear the whole night, so I just decided to take my one-shot color camera and hook it up to my refractor and just do some classical imaging, I guess, on the horse head and the flame.
You weren't able to catch the comet while it was there, were you?
I didn't even think of it, Randy, at the time, to be honest with you.
Okay.
That's all you're going to say on this one?
Yeah, pretty much.
Okay.
It came out really good. And
Yeah.
while I was waiting for this to rise, I think you skipped past the Pleiades there, yeah. So I just captured some of these while I was waiting for the horse head to come above the horizon. And I'm surprised how well they came out as well.
Excellent.
Very
Beautiful picture. All right. Thanks, Jim.
Tinsel.
Okay, Jim.
Good evening, everyone. I hope you can hear me.
Hi, Jim.
Yes, we can.
Yeah, this is a shot that I took on November 1st, which was a day after the full moon, and the moon was rising pretty high in the sky. So in St. John's, we don't have the greatest of weather, and clear skies are at a premium. So we did have a few hours of clear sky that particular evening. So it was an opportunity to get out. So fortunately, I've just purchased a new filter for, which is basically a tri-band filter. And I decided to test it out for the second time by taking a shot of the Heart Nebula. This is something that I've attacked before. Now I didn't know what the optimum exposure was, and I was having trouble with my system with the guiding, and I found that taking exposures unguided worked much better. So I took 14 5-minute exposures with this tri-band filter and a modified Sony A7 full frame camera. And what I got initially wasn't too inspiring. It was basically a fairly uniform greenish color. But after doing a background subtraction in Insight, out popped something that was remarkably similar to what you're seeing on your screen right now. And in terms of the physics of what's going on there, we have a number of different things going on. The brightest part of the nebula is the Fishhead Nebula, which is in the lower right-hand corner of this image. Most of the yeah, right there, good, thank you. And then most of the luminosity is from H2 emissions, which H alpha, and I think there's always a little bit of H beta associated with H alpha emissions. Chris can correct me later, I think, but I think that I was unusually surprised by the lovely color that came out of this this image. The center, at the very center of the Heart Nebula, is a loose cluster of stars. The bigger stars are 50 times the size of the sun, and that is really the engine that's driving the luminosity of this area. So you can see there's lots of dust lanes and lots of details and star forming regions that are evident in this particular photograph. So anyway, I'm really pleased with this particular result. It turned out much better than I expected, and it just shows that since this was actually taken in basically in Pleasantville, in the East End here in St. John's, you can get some spectacular shots of deep sky objects using what I would call a narrowband filter with a one-shot color camera. And so I'm looking forward to some clear skies over the next few months in the new year.
Yeah. And during full moon too.
Well, any time.
Nice, Jim. Thanks very much for sharing. Now we've had a member I talked about earlier. John Peddle. Can you hear me, John?
Yes, can you hear me?
Yes, we can. I just want to congratulate you on getting your, has it arrived yet from the national office?
Actually, when you mentioned it earlier, that's the first I heard it was like approved.
Yeah.
Oh.
Yeah, I was going to talk about it, but Gary kind of.
Oh, that's fine.
Yes, I wanted to congratulate you too. I just wanted to say that as the observing director, and that it's an amazing accomplishment, and I really hope that it inspires more people to do that, because you do learn a lot. And
yeah, you really.
Yeah, and it pays off. It's rewarding, not just for the certificate, but having done it, it's very rewarding. It turns out that COVID kind of broke the system, so the observing committee at national didn't really know what to do, because you had to have 2 members of our center approve it. And first they were like, okay, no, it's COVID, we won't do that. And then they were like, no, we actually have to do it. And then they were like, oh, let's do electronic signatures. And then they were like, okay, maybe that's too complicated. Just have 2 people email us. So we finally did that. We had 2 people email them, and they approved it today. And okay, it should be mailed to you anytime now. So hopefully you can, if you get it for the next meeting.
I'll drop everyone a note when I receive it.
Okay. You want to tell us a little bit about how you did it?
Well, I started with the form that you find on the website with the Q+ days and the Q- days, like before the quarter moon and after quarter moon. But I found in Newfoundland is a little bit off. So the first thing I do was just find an obvious target and just go for the smaller targets from there. And like it is, moon's very, very, very interesting subject. Like lots of craters and mountainous regions and fault lines and that kind of thing. And really, really, really developed new interest for the moon.
Yeah, I loved your sketches. I was reviewing your notes this morning, and I was using an app called Lunar Atlas to
Okay, yeah.
verify. And I have a big appreciation for the work you went into this.
Yeah, it was a 13-month process actually, and it might have done it sooner, but with the big storm we had in January, it was like 3 months I couldn't get in my backyard. So
Yeah, Susan's working on hers, and
yeah,
she was saying that it was the same type of thing. Thanks very much, John.
Yeah,
Greatly appreciate it. And
yeah, there were a
hopefully
few
you'll
things.
get your things for next meeting.
Yeah,
when we see
I'd like
your,
to say to Sue,
medal.
I'd like to say to Sue, there were a few things took me a couple of occasions too to try to get, but I did eventually get it, and I wanted to be sure I saw it, so I said I'm not sure if this is it, so I'll try it another night. So yeah, stick with it.
Good.
I've been trying to do.
Yeah.
Sue, are you working on the lunar one as well?
She took herself off.
No. Can you hear me?
Yes, we can now.
Okay. Yeah, no, I started it last fall, and then I kind of had a big break during the summer for various reasons, but I'm now working on it again. And I've just got a few to go, but like today and yesterday was supposed to be the prime times for looking at the features I wanted to see. And of course, the sky is completely clouded over, so I can't do it. So you just have to be patient, really, and recognize it will take a lot, especially with binoculars. I mean, it's not very easy with binoculars.
No.
But, you know,
even, yeah. There was 10 or 15 minutes you could see the moon yesterday evening.
I know, and you know, I did see it for a few minutes, and but I'd got some trees right in the way.
Yeah.
So I thought, well,
teasers, yeah.
Yeah, I thought I'd leave it for 10 or 15 minutes, yes, and go back. And when I went back to look, it was gone.
Yeah, that happens.
Yeah.
I just put up some pictures here from Chris Go. I got permission to talk about it. We talk about dust storms, and it's usually hard to see a dust storm, but I just want to show you this one here. Those people right here, let's see. Here's my thing. If you look at this picture here, this here is Mariner Valley. We see a dust storm coming here. Okay. And here how it's expanded. Look, right up the valley. I thought it was one of the best examples of a dust storm going right up the valley. It's now gone all the way to Cyrus Majors. But I thought this was interesting. If you look over here, there's no dust storm, but this valley here seems like it goes underneath and pops up here. I'm wondering if it does go underneath, or is this just another storm? The latest ones, and as you can see, it's also spread up here, but it's also spread there. But I just thought this was a fantastic picture showing the storm starting right here and going right up the valley. I thought it was excellent type of thing. Anyway, with that, I guess, do we have anything else before we end the game?
No, we have another 2 speakers lined up for the next 2 meetings. So should keep us going for a while. Normally for the December meeting, we'd have a little holiday get together, but we can't do that this year.
Okay, that's everything. I want to thank everybody for the meeting. It was an excellent talk given by Peter. Hope it inspired you to go looking for asteroids. I was inspired both by John and Sue going, I'll open up my book and see if I can finish my 100 images of Mars, or the moon, actually. I'm too busy looking at Mars right now to do anything. But I want to say thanks everybody for coming tonight. Hope you enjoyed yourself, and good night.
Good night, Gary. Good night,
Good night.
people.
Thanks, everybody.
Yeah.
Thank you very much.